So for number 22, we're talking about the surface area of a cone, whose formula is pi r squared plus pi r L. And they tell us that the surface area is 4354. So of these variables, radius and slant height, which do we know? We know what the radius is, half of the diameter. So if the radius is 21, then we know everything we need except for L. And that's important because to find the height of this cone, that's this dimension here. The distance from the base of the cone to the vertex of the cone. How are we going to find that? Well, like I said, they've given us the surface area, and with the formula and the given radius in this picture, we can find the slant height, which in the picture is this dimension, which means we can use this right triangle in this picture. They wanted to know the height, and we can do that using the Pythagorean theorem and this right triangle. But we can't find height until we know L, slant height. And thankfully they gave us the surface area. So with this formula, we can find the slant height, and then we'll substitute it into the Pythagorean theorem and find what they're looking for. Here we go. So square 21 times pi, and then solve for L. So let's subtract 1385 from both sides. All right, so it's gone on the right, and we subtract from the left. Next, we'll divide both sides by 65.97, etc. And the right side divided by that leaves us with the slant height, and the left side leaves us with about 44.996. Now that we know the slant height, we can find the height using the right triangle and the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Slant height, which is the hypotenuse of this right triangle, is 44.996. Let's substitute it in, and we'll find h. All right, so 44.996 squared gives us this, and we'll subtract the blue 441 from both sides. And the last step to find the height, h, is to take the square root of both sides. And when we do that, we'll know that the height is approximately the square root of 1583, which is about 39.8. There are 6 sides, so the area of this regular hexagon will be the area of 6 of these red triangles. So the triangle's base times the triangle's height times a half is the area of one triangle, and 6 of those triangles will be the area of the entire hexagon. So what's the base and what's the height? From the center to the corner is 8. This triangle, we need to know this length, and we need to know its height, base and height. So how are we going to do that? An entire revolution is 360. So if there are 6 triangles, 1, 2, 3, 4, 5, 6, the central angle will be 60 degrees. And that blue altitude divided the 60 degrees into 30 degrees. So we have a 30, 90, 60. And in the 30, 60, 90, the hypotenuse gets halved to give you the short leg. So short leg is 4. And the long leg is that short leg times root 3. So h equals 4 root 3. All right, so the base of our triangle is 4 plus 4, which is 8. And the height is 4 root 3. Half of 8 is 4. 4 times 4 is 16. 16 root 3. So the area is 96 root 3. Or whatever that is a decimal when you put this in your calculator. All right, if you like the formula for regular hexagon areas, that would be 1/2 AP. So the apothem is the distance from the center to the midpoint of a side, which is 4 root 3. And the perimeter, P, is the perimeter of the base, which is 4 and 4 is 8, and 8 and 8 and 8 and 8 and 8. 8 times 6 is 48. And when we simplify all that, we get the same thing.